Chalo. Let's begin up then. Right. Double E and EC both Naveen. Right. Yeah, great, Tarun. Good evening, Ravi. We'll see the possibility, Manish. We'll try if the schedule allows in the next week. Okay, so in this digital, we'll cover up the PYQ of double E plus EC both, and that is what is the benefit, right? Because it's a common subject, double E students should practice EC questions. EC students should practice the double E questions for more detailed practice and for more variety of questions, right? All right. So guys, let's get started quickly. Then this is a brief intro in case somebody new to my class. This is Rakesh. I have secured All India rank 9th in the gate, completed my masters from Indian Institute of Science, Bangalore, and these are my major area of expertise that I've been dealing for more than 12 years, right? All right, good evening all. And yeah, so that is what is the quick update of the GATE PYQ series, where we are covering the questions of 2018 to 2022, and it is a live subject-wise discussion already started from 18th December, that is 2 days back. And if you were not aware, you can just note this update, and in case you don't forget any other sessions or any other updates, do not forget to subscribe the channel right now so that you get all updates and all sessions without any miss. Okay, so now let's get started, guys. Question number 1 quickly. Okay, with every question I've mentioned the year and the mark and the branch as well. It's a easy 2021 1 mark question. 1235x is 3033y, where x and y indicate the bases of the corresponding numbers. Then what could be the possible values of x and y? Right, it's good, it's better, Raghu. Chalo. So very simple question on the number system, chapter by chapter chalenge. So it is 1235x has same value in base y, which is 3033. Okay, now because these are two different bases, we can convert both into decimal and start solving the question, right? We can convert both into the decimal, and that is what can be a good approach for us to converting this into decimal. Digit into base power position. So what is the position here? Right, this is position 0, 1, 2, 3. This is also the position 0, 1, 2, 3. Both are 4-bit cases. So 1 into x ki power 3 plus 2 into x ki power 2 plus 3 into x ki power 1 plus 5 into x ki power 0 is equal to 3 into y ki power 3. Right. Then we have the digit 0. Okay. Then we have the digit 3 into y ki power 1. Then we have the digit 3 y ki power 0. Isn't it? So eventually we have x cube plus 2x square plus 3x plus 5 x power 0 is 1. That should be equal to 3y cube plus 3y plus 3. Isn't it? Now remember that there is no point of solving. These are two cubic equations, expressions to be equated. Okay, that is what we know. And one more thing we can know, that 1, 2, 3, 5 is in the base x. So x has to be greater than 5. 3033 is in base y. Y has to be greater than 3. Okay, but all of the options has this. So what we are going to do now, we're just going to match the options, right? Okay, we are just going to match the options as per the given options. Guys, if it is by chance a MSQ question, I will mention that. Okay, whatever the MSQ questions are asked, wo bhi leke aaya, but we'll match that. Once you match the option, guys, calculations you can complete. I believe you are going to get the answer as A. Okay, I can trust that you can just use your virtual calculator and complete the calculation. Whenever you put x equal to 8 and y equal to 6, you are going to get the correct answer. We are going to get the correct answer, right? Very good. Okay, so I hope you will complete the calculation part. Let's look into the practice and approach of the questions rather than, involving the time in calculation. Next question coming up here, again a number system one. If PQR, so it was a good question of number system that was asked in 2020 for 2 marks. If PQR are the decimal integers corresponding to the 4-bit binary number 1100, considered in signed magnitude, 1's complement and 2's complement respectively. I repeat, PQR are the decimal integers corresponding to 4-bit binary numbers. Okay, corresponding to the 4-bit binary number 1100, considered in signed magnitude, 1's complement and 2's complement respectively. What is the 6-bit 2's complement of P plus Q plus R? Right. Hi, good evening, Tushar. So there is a 4-bit binary number P1100. P is its value in signed magnitude, decimal value, right? Q if it is 1's complement number, R if it is 2's complement number. So we have one binary combination given to us. Okay, now let's talk about P. signed magnitude. Okay, first is signed magnitude. So everybody, in the signed magnitude, we know that we split the number into sign and magnitude. This part is the magnitude. This is known as the sign, meaning it is a negative number because sign equal to 1 represents negative number. Good evening, Payush. And magnitude 100 is equal to 4. Right. So in the sign magnitude, I call this as P, and P is equal to the -4. Magnitude 4, but it is negative. Okay. Now analysis of the same number. If it is ones complement number. Right, if it is the ones complement number. Now, how do you get the decimal value of a ones complement number? Right, so again, 1 bole to negative. So it's a negative number, right? It's a negative numbers, right? So not directly but indirectly, Ravi, it is important. I'll show you one question also where you need to have a quick understanding of number systems. ठीक है? ये ध्यान रखना है रवि. चलो, so 1100 and anyways less questions are there. Double E में तो बहुत कम आता है. EC also less questions, just 1 or 2 questions in 5 years, and then we are moving towards the other topic. Good evening, Ela. Okay. Now it is a negative number. Because it is a negative number, so we will take its ones complement, and ones complement is 0011, right? And which is equal to 3, which is equal to 3 in decimal. So this number, which is Q. Okay, in the ones complement, I call it as Q, and Q is equal to magnitude 3 hai, and sign is negative. Q is -3, sir. Q is -3. But suppose 1100 is a number stored in a 2's complement machine. Is a number stored in the 2's complement machine, 1100, dear. Okay, so once again, I will see that 1, bole to negative, and because it's a negative number, I will take its 2's complement, because negative numbers have been stored taking the 2's complement. So I again take the 2's complement because complement will cancel each other. So iska 2's complement kitna hua? 0011 is the 1's complement plus 1. So it will become how much? Sorry. It will become the 0100. That is the 2's complement. Okay. 1's complement adding 1 to the rightmost bit. Okay. 0100. And this is equal to 4. Right. So if I call this number as R, this is -4. Right. Because in the 2's complement, the number is written as R, and in the 2's complement, it is given by -4, right? Okay. No, indirectly it is there, Tarun. Okay. CSE में तो important है, but it is there indirectly in the number system. I will show you the question. देखो यार, बिना number system के digital, see, direct questions are not there in EE, indirect questions are there, and EC also less questions यार, ठीक है? So what is the value of P plus Q plus R in 6-bit 2's complement form? तो पहले, भाई साहब, what is P plus Q plus R? Right, P is -4, Q is -3, R is -4. This is total -11. Right, this is total -11. So everybody, what is 11? 11 in binary is 1011. 11 in binary is 1011. ठीक है जी? 1011. But in 6-bit, it becomes 001011. 6-bit में convert करना है ना? 001011. That is the number in 6-bit. Okay. Now, this is the magnitude 11. What about -11? -11, right, will be obtained by taking the 2's complement. Because it's a negative number, so we need to take the complement. If I ask you +11, answer is 001011. Okay. But it is -11, so I have to take its complement. So that will become 110100 plus 1. So directly likha 101. So my answer, dear, -11 equal to 110101. 110101. 110101. Option number B. 110101. That's the correct answer. Option number B. Moving ahead to the next question. A function f ABC is defined by 3 Boolean variables ABC when expressed as a SOP. A function f ABC is defined by 3 Boolean variables ABC when expressed as a sum of product is given by a bar b bar c bar plus a bar b c bar plus a b bar c bar. Correct? Where a bar, b and c bar are the complements of the respective variables. ठीक है, ये b bar होना चाहिए. And we know that what is the meaning of bar. Okay, the POS form of the function. The POS form of the function, guys. Come on. Boolean question. Basic Boolean question. So what is this min term? 0, 0, 0. 0, 0, 0 is 0. 0, 1, 0, 2. 1, 0, 0, 4. 1, 0, 0 is 4. Correct? Now the same function when expressed in the POS form, so POS form के लिए what we usually do is, ध्यान देना, तो f is summation of the minterm 0 to 4. What is the method usually I follow is taking the complement first of all, that is 1 3 और 4 भी हटा देंगे, 5 6 7, and then applying the De Morgan's. Okay, first simplify this function using the K-map. First simplify the function using the K-map. Okay, so this session also looks like a good practice for all of you. This is A. अरे मैंने 5 क्यों बना दिया? I'm sorry. Correct. This is known as the A, this is known as the B, this looks like the C, and then we have the numbers, 1, 2, 3, 4, 5, 6, 7. Do the pairings quickly. Okay, this is definitely, okay, not pairing. This is a quad very clearly, and this is one pair. So we have a quad and a pair. Correct, Aji? We have a quad and a pair. 1, 3, 5, 6, 7, Ela. Even 6 will come. Just check the numbers, and this particular pair, this is in A as well as B, and this is the quad which is directly in C. So I can say that my function f bar is equal to AB plus C. My function f bar is equal to AB plus C. Now, but if you are able to look, all the options are not representing minimized form. All the options are not representing minimized form. Okay, so if I don't want the minimized form, I can directly get the product of max term. What are the product of max terms? So तो यहीं पे लिख सकते हैं 1, 3, 5, 6 and 7. And that is why it's a 1 mark question then. What is the product of the max terms? 1, 3, 5, 6, 7. It's like M1, M3, M5, M6, M7. That is a direct SOP form. Okay, that is a direct POS form. Sorry, POS form. अच्छा जी. अब what is M1? What is the max term? It is the complement of corresponding minterm. How do you identify that max term? It is the complement of the minterm. And what is the minterm M1? 0, 0, 1. That is A bar, B bar, C का whole bar. That is A plus B plus C bar. A plus B plus C bar आना चाहिए. Right. So A plus B plus C bar has to be there. Okay. So पहले कौन सा option आ गया? A plus B plus C bar. A plus B plus C bar. Okay. यहाँ आया. Right. And that's I think only thing. इसको थोड़ा सा ऊपर कर देते हैं. Let me check. Yeah, है ना? A plus B plus C bar. Okay, so either C or D. Then I can check the M3. Right, guys, what is the M3? It is small m3 whole bar. Minterm का complement. That is A bar B C bar whole bar. That is A plus B bar plus C. A plus B bar plus C. A plus B bar plus C. तो ये आ जाएगा. Yeah, so it is going to be option number D. Just match all of this. C नहीं आ रहा है. नहीं, C is not matching ना. A plus B plus C bar. Then I have the M3. M3 is A plus B bar plus C. अरे यार. Sorry, a typo error from my side. I'm sorry for this. This is zero double one, and hence it is A plus B bar plus C bar. Sorry, A plus B bar plus C bar. Yeah, the correct option that is matching is C itself. A plus B bar plus C bar. Correct. It's C. Okay, it is C. Done. Okay, it is the C, and that is done. We have matched it. Okay, we have matched it. Now, guys, if they asked you the minimized form, suppose if they were asking you the minimized form, then this is the procedure to be applied, right? So then F is going to be A bar plus B bar is multiplied by C bar, because this is the F complement. Now applying the De Morgan's law, I will take A plus B bar is multiplied by C bar. This is known as the, यही लिख देते हैं, this is known as the minimized product of some form. Okay, so one of them is minimized. This one is the canonical form, directly in the max term form. Okay, done. Simple 1 mark question. Next question. The output expression for the K-map shown below is how much? The output expression for the K-map shown below. Directly a simple K-map question. Double E 2019, 2 marks. See, sometimes for double it is that easy. 2019, 2 marks, very simple question. Okay, so what is that expression? Look into the variables, the type they are given. P, Q, right? P is high, these two cases. Q, second bit of PQ, right? So this should be Q. Regions को accordingly ध्यान रखना. RS, this is R. R, S. S is the second bit. These two are high. So I'll write down S here. These are the regions very clearly. And now, what is the groups that you can make? Okay, these two one along with these two one. No need to take a pair, clearly a quad. Okay, and this is the octa. 1, 1, 1, 1, 1, 1, 1, 1. Clearly a octa. One quad and an octa. One quad and one octa, very clearly. Right, so this is going to make, this is going to be directly S. It is completely fitted in S. And what about this one? Ye tha P, hai na? So what is this one? This is Q and above R. So R bar Q. R bar Q, right? So it is going to be S plus R bar Q. It is going to be S plus R bar Q. Option number B mark kar diya. It is the option number B. Very, very simple. It is the option number B. Very simple for 2 marks, right? Very simple for 2 marks. Next question, EE 2018 2 marks. This is also simple. See, so you can sense EE mein K map is important. Very simple topic and 2 marks they are putting up. The digital input signal with A as the MSB, C as the LSB is used to realize the Boolean function M0 plus M2 plus M3 plus M5 plus M7, where Mi represents the ith minterm. Small m is always commonly used to represent minterm. F has a don't care for M1. So what is F actually? If I write down in the list form, na, summation M 0, 2, 3, 5, 7. Ye sab to aa raha hai. Plus it has a don't care possibility. Summation of don't care. Which one? 1. Okay. Quickly here itself, let's feed this in the K map and get hold of the answer. Let's feed this in the K map and get hold of the answer. A, B, C, and the minterms are 0, 2, 3, 5, 7, and there is a don't care at 1. There is a don't care at 1, and because of that don't care, see, usually you will take this as pair, but don't care is available, so you will take it as a quad, because don't care can be 1 or 0 based on your choice. How do we make the choice? We have to minimize the function, and that is why we have to make larger groups. Similarly, these two ones could have been paired, but now because I am taking x equal to 1, this also becomes a quad, right? And this is outside A. This is a quad within C. So A bar plus C, option number B. It is known as the A bar plus C. It is the option number B, right? Good evening, ABD. It is known as the A bar plus C. It is known as the A bar plus C. Done. Next one. Select the Boolean function equivalent to. Now, look into this. 2022 EC 1 mark MSQ question. MSQ question from digital. MSQ question, multiple select question. Okay, select the Boolean function equivalent to x plus yz, where x, y, z are the Boolean variables and plus denotes the logical operation. ठीक है, अब आप देखेंगे x plus z plus xy, how much is this equal to? इसमें से x common लेंगे तो you will have 1 plus y plus z. 1 plus y is 1, so this is x plus z. So this is not equal to x plus yz very clearly, right? X plus y, x plus z is x plus yz. Distributive property है dear ये. You can even multiply and prove it. But this is just the distributive law, so no need to prove it. Okay, no need to prove it. Next is x plus xy plus yz. X common liya, so x into 1 plus y plus yz. So 1 plus y is again 1, so you have x plus yz. This is also correct. Okay, last may say you can take x common, but x is common from all. 1 plus z plus y is left and 1 plus anything is 1. So this is x. So what are the options matching clearly? It is a multiple select question. 1 or more options can be correct. So 2 options are correct here, B and C. 2 options are correct here, that is B and C. Very simple for MSQ. Very simple for MSQ. ठीक है जी? Very simple for the MSQ. It is the very simple for MSQ. It is B and C. It is given by the answer B and C, right? Chalo. Right? So ABD, basically we are discussing the previous year questions of digital for EC and EE, but useful for CSE, right? Useful for CSE because you have separate questions. You know why you only focus for COC? You can also try EC EE questions. You will get a good variety. So it's up to you. It's a PYQ of EC EE, but CSE ko practice kar lena chahiye if you have time, if you have the bandwidth. Chalo. In the logic circuit shown in the figure, Y is given by. Very simple question for EE for 1 mark. Okay. So this is what? This is a very simple circuit. NAND gate A, यहाँ पे करते हैं. Let's do it here. Let leave the question. NAND gate A into B whole bar, NAND gate C into D whole bar. Okay, and now what you can do is you can replace this NAND gate. Okay, you can replace this NAND gate by its equivalent structure. What is the equivalent structure of a NAND gate? NAND gate is what? AND gate followed by a bubble. It can also be represented as a OR gate preceded by bubbles. OR gate preceded by bubbles. OR gate preceded by the bubbles. ठीक है जी? You can also represent it like this. So what is coming up here? AB whole bar. What is coming up here? CD whole bar. ठीक है? So that means bubble and bar and bar will cancel, bar and bar will cancel. Your answer will be AB plus CD. Your answer will be the AB plus CD. That's it. Your answer is going to be the AB plus CD. Okay, it is D. AB plus CD. Okay. If you don't, if you're not able to recall this connection, you can even solve this. You can again solve it as a NAND gate. तो भी आ जाएगा. That was also okay. How? Now that is also very simple. अब ये क्या हुआ? Okay. This is like suppose X and Y. This is X and Y whole bar. So it is like AB bar multiplied by CD bar का whole bar. तब भी तो solve हो गया. There are two ways of looking into it, ना? Right, AB bar into CD bar whole bar. Now apply the De Morgan. Right, so AB bar will be AB plus dot becomes plus. CD bar will become CD. AB plus CD. Done. Okay, so the correct answer is D anyways. Okay, next question की तरफ जाते हैं. In the circuit shown below, X and Y are digital inputs. Okay, now see double E, how bonus you get, yaar. Double E, how much bonus questions you get? 2 marks. Okay, X and Y are digital input, Z is the digital output. This is equivalent to what? Arey sir, this is equivalent to how much? This is X bar Y. Okay, and what is coming up here? This is X multiplied by Y bar. दोनों को add किया, X bar Y plus X Y bar. Everybody knows it is the XOR gate. Arey sir, how simple it is. Can you believe double E 2 mark question? It is the XOR gate. Done. This is the XOR gate and done. Okay, next. Right. EC 2018 2 marks. Good question. Just read and understand this completely. Okay, so what do we have? Logic gates. The logic gate shown in the digital circuit below use strong pull down NMOS transistors for low level logic at the outputs. Okay, when the pull downs are off, high value resistors set the output logic level to high. We will see whatever is required from here. Note that some nodes are intentionally shorted. यहाँ पे आएंगे. Some nodes are intentionally shorted to implement wired logic. What is that? See, normally you should know what is wired logic. Even if you don't know, they have explained that briefly in the question. Such shorted nodes will be high only if the output of all the gates whose outputs are shorted are high. I repeat this. Such shorted nodes will be high only if the output of all the gates whose outputs are shorted are high. Okay, dekho. Now this is one shorted connection. Outputs of 2 gates are coming here. One is the XOR and one is the inverter. क्या बोला है? Such shorted nodes will be high if the output of all the gates whose outputs are shorted are high. मतलब output of this gate and output of this gate should be high. So effectively what type of gate? Effectively what type of gate? Yeah, just 1 or 2 such questions you can find ABD. Hai na? Effectively what type of gate? Hey, this node will give a high output when it receives both 1 1. So effectively it is like that wired logic is just like implementing the AND gate. Can I say like that? And then it becomes a simple. Then it becomes a simple. Okay, so this can be effectively assumed as a AND gate, and this can be effectively assumed as a AND gate. Is that okay, everybody? Is that okay, everybody? Okay, now this is X0, so this is X0 ka bar, and this is directly X0. Okay, and this is the output of XOR gate. Now whatever it is, guys, okay, whatever is the output of this, whatever the output of this is, suppose this is F and this is applied here, but very important point is this is already an AND gate, F into X0. So what is the output here? F into X0, and this is also a shorted case, this is also wired logic, so is multiplied by F into X0 multiplied by X0 bar. So eventually F X0 X0 bar and A into A bar is 0. So what is the important result here is this becomes 0. So ultimately this becomes 0, and then the final output Y, and then the final output y is just equal to 0 plus यहां से कितना आया, यहां से आया x3. It is 0 plus x3 का बार भी नहीं, it is 0 plus x3 directly, right? So what is the output y? Y is given by the x3. Y is given by the x3. अब क्वेश्चन में क्या बोला है? The number of distinct values of x3, x2, x1, x0 for which y equal to 1. Y is equal to x3, y is equal to MSB. Any bit will be 1. Whether it is MSB, LSB, for half of the times, it will be low for rest of the times. Right? Okay. So y equal to x3 will be equal to 1 for how many times? For 8 times. Total 16 combinations होता है ना? Going to be 8 times, right? What are those 8 times? देखो 0 0 0 0 up to 0 triple 1. MSB is low, right? 1 triple 0 up to the 1 1 1 1. MSB equal to 1. आधे टाइम लो रहेगा, आधे टाइम हाई रहेगा. So the number of distinct values for which y is equal to 1 is given by the 8. Is given by the 8. Is given by the 8. Done hai? It is given by the 8. Chalo, done. Right. So next question here. Again guys, EC 2022 2 marks MSQ question. Second MSQ question in 2022 from digital only. Only from digital second MSQ question. See, only and only from digital. Only and only from digital second MSQ question आ गया. Consider a Boolean gate. So it's a good question. They are asking to develop a Boolean gate. Actually very simple but good. The output y of that gate is given by y is equal to a plus b bar, where plus denotes the logical OR operation. So you can use the OR gate there. The Boolean input 0 and 1 are also available separately. Using the instances of only D gates and the input 0 and 1, select the correct options. Matlab, what all gate it can implement or cannot implement. Questions are NAND and NOR or an AND. भाई अगर by chance NAND implement कर दिया तो automatically AND will follow. Right? If it is able to implement NOR, it will be able to implement OR also. It's a very logical thing. Okay, by the way. है ना? Now, the gate. What is that Boolean gate? What is that Boolean gate? What is the Boolean gate D? It is something like this. It implements the functionality A plus B bar, and what can be its possible logic diagram? Logic symbol, right? It has the input A and it has the input B bar. So I will show a bubble. I will show a bubble at its input. Okay. Related to universal logic theory. Okay. Right. Okay, Payash. Right. So y is equal to a plus b bar. Now, can you first of all make a NOT gate out of this? Can you make a NOT gate out of this? So, देखो, what I will do is, this is the given gate. Now, what I will do is, ध्यान देना. Okay. First, can it make a NOT gate? Yes, it can make a NOT gate. A plus b bar में let a equal to 0 and put b equal to a then. I'm telling you, 0 and 1 are also available. 0 and 1 inputs are also available separately. Right. So the first input I make it as 0 and apply A on the second one actually. So this is equal to how much? This becomes 0 plus A bar and this is A bar. So this is a NOT gate effectively. This is a NOT gate effectively. ठीक है, ये done हो गया. Now, if it can implement NOT gate, can you go for NAND gate? Bhai, what is NAND? AB whole bar. AB whole bar is A bar plus B bar as per the De Morgan's law. So A plus B bar it can already implement if you are able to get that A bar extra, right? A bar ऊपर से ले लेंगे तो देखो. I'll take the first example. I'll take the ऊपर वाला example. This goes here. This is equal to A bar, everybody. Right? Now plus B bar. Okay, so this A bar can be fed here using the second of this. Now this A plus B bar actually is going to implement A bar plus B bar. A की जगह A bar feed किया है and that is what is the NAND gate. So yes, it is able to implement NAND gate. It is able to implement NAND gate. Is it able to implement NOR also? So dear, what is NOR? NOR is A plus B whole bar or it is equal to a bar b bar? ये बताइए. Can it implement a plus b whole bar? Can it implement a plus b whole bar or a bar b bar? Let's think about a plus b only because this is a type of plus operator. So it's better to think about plus. No need to take a bar b bar. So only think about the plus wala case, a plus b whole bar. Can you think about a plus b first of all? Yes, you can think about a plus b if you invert this b. Extra inverter if you use for this. Okay, so पहले आ जाते हैं. I need to invert b. Everybody pay attention. I have to first invert b. To invert b, first input should be 0 and second should be applied as b. So this becomes the b bar. Okay, now what I will do is again I'll use the d gate, boolean gate d. Here I will apply regularly a and here the second input is b bar. So now your output is how much? A plus b bar. ध्यान देना. A plus b bar bar. Already b bar and then going to the inverter. So a plus b bar bar which is equal to a plus b. But I want a plus b whole bar. I know how to invert now. One more inverter is required. To invert this, again use the boolean gate d. Right. Where the first input has to be 0 and second may you feed a plus b and then it behaves as an inverter, a NOT gate, a plus b whole bar, that becomes a NOR gate. So yes, it is able to implement NAND and NOR as well. Now ध्यान से option देखना. NAND logic can be implemented? Yes. NOR logic can be implemented? Yes. If NOR logic is implemented, what about OR? OR can also be implemented. So yo, this is wrong option. If NAND is implemented, AND will also come. How? One more inverter will be there ना. देखो OR तो already आ गया था. यहाँ तक OR तो already आ गया था. So OR is possible. Similarly, I have drawn NAND ना. I have drawn NAND. Put one more inverter at the last, you will get AND also. So if NAND possible, then everything is possible. NAND and OR, you must know universal gates hota hai. So A and C correct. OR can also be implemented and can be implemented, but they have written reverse. But they have written the reverse. Okay, they have written the reverse. Done eh? Okay, so the correct answer for the MSQ question, it is a 2 marks MSQ question based on the universal logic. It is A and C. It is A and C. Now, not exactly this one. Let me tell you one example. Not exactly this one. Somewhere in 2010 and 2014. Somewhere in the year 2010 and in the 2014. There were questions based on universal logic and there was a gate given as A plus B bar. Statement totally different tha. Statement was different. But if you just go and look into that gate 2010 question especially, if you have understood that, if you know what type of questions can come, you can solve this. You can 100% solve this if you know the concept. ऐसा नहीं कि उसको रट्टा मार लिया. If you know the concept of gate 2010 question, universal gate पे question था, you can solve this question also. Regular, otherwise also you can solve. Okay, but you will be really confident. That is how PYQs are important. Concept repeat होता है. Not exact word to word, but concepts, are repeated. Okay. ठीक है? Ravi, exactly repeat your doubt, please. Okay. Chalo. That is why PYQs are always important for you. Okay. And that is the whole reason we have brought you this series. Okay. Especially 5 years. Now, the figure below shows a multiplexer where S1 and S0 are the select lines I0 to I3. I0 to I3 are the input data. Very simple 1 marked mux question. Okay. EN is the enable. It is the active low enable. It is the active low enable. That is why fed with the 0. Okay. So it is enabled. This is enabled. What is the output, guys? Very simple. The output is select line 0, 0, P bar, Q bar into I0. I0 pe hai R. Select line 0, 1, P bar, Q multiplied by the I1. That is 0. Select line 1, 0 multiplied by I2. That is R. Select line 1, 1 multiplied by I3. That is equal to 1. Okay? Very simple question. That's it. Okay. So ये कितना हो गया? From the first two terms, first and third, second to 0 here. From the first and third, what I can take common? Actually, I can take the common as Q bar R. Right? P bar plus P will be eliminated. Plus PQ. The question is solved. Q bar R plus PQ. No further simplification possible. Nothing else is common. So PQ plus Q bar R. PQ plus Q bar R. Option number C. Option number C. Right? First universal logic, Ravi. First NAND and OR की बात करते हैं हमेशा. Okay? चलो, this is done. Option number C is the very correct answer. Let's move ahead to the next. consider the 2-bit multiplexer shown in the figure for the output to be the XOR of C and D. What should be the value of the input line? Now, normally to decide the value of the input line, we use the implementation table, but not really required here. Not really required here because it is a very simple type of case given. Output has to be XOR of C and D. Output, suppose it is Y, it is required to be XOR of C and D, and that is given by C bar D plus C D bar. C bar D is 0-1 combination, C D bar is 1-0 combination. Okay. So anyways, if you want C bar D, 0-1 ke saath I1 is selected. So activate this line. C D bar, that is 1-0. I2 is selected. So activate this line. Okay. Activate this line. So this simply means if you want to select this, A1 should be 1. And if you want to select this, okay, the A2 should be 1. Correct. Rest, both of them should be 0. Right. Rest, both of them. A0 should be 0. A3 should be 0. So 0, 1, 1, 0. 0, 1, 1, 0. It is the option number C. You can do with the implementation table also, but this is a direct answer. 0, 1, 1, 0. Finished. Khalas. Done. 0, 1, 1, 0. Next question ki taraf aate. Okay, it's a 2-mark 2018 EC 2 marks. Very simple question again. Simple, very simple. Scoring for 2 marks bolenge isko. Okay, question kya bola hai? A 4-variable Boolean function is utilized using a 4x1 mux. Okay, 2 cascaded 4x1 mux. What is the minimized expression of f, u, v, w, x? Pehle aa jate. Look into this, guys. What is the combination given? 0 and 0 at the I0 and I3. This is VCC, matlab 1 and 1. So what is the input combination here? 0, 1, 1, 0. You can solve again, but just last question we have repeated. Na? Last question we have done. So I can say this will implement XOR of the select lines. It is going to implement the XOR of the select line. Okay? And the same thing goes to the I0 and I1 of the next multiplexer. I2 and I3 are 0. Okay, yahan pe bhi aa jayega U XOR V. Now, what is the final output F? Very simple question. Select line 0, 0. Now, select lines are WX here. So, 0, 0, that is W bar X bar into I0. Into I0, that is U XOR V. Plus select line 0, 1. That is W bar X into U XOR V. Very simple now. You can take the U XOR V as common. Then you are left with W bar X bar plus W bar X, out of which again you are able to take W bar common. X bar plus X will be 1. So your final answer is U XOR V is multiplied by the W bar. U XOR V is multiplied by the W bar. Right? U XOR V multiplied by the W bar. U XOR V is U bar V plus UV bar. Not the D1. ये ध्यान रखना. D is not correct. You know, some of you might look, sir, ये भी तो correct है. This is also what we have written. W bar X bar plus W bar X. But this is not correct because question has clearly specified that you have to tell me the minimized expression. You have to tell me what? You have to tell me the minimized expression. Done hai? Let's move ahead to the next question. Now see. Again, I repeat the role of PYQs. Role of PYQs. Similar question. See, it's a question based on multiplexer with the propagation delay, with the worst case propagation delay or maximum propagation delay. A very similar question in 2016. A very similar question in 2016, ISC Bangalore. If you know to solve that 2016 question, 200% you can solve this. Exact same approach. Exact same approach. Only thing is the circuit is slightly changed. पूरा तो कॉपी करके नहीं दे देंगे वो. Maybe, you never know, because propagation delay questions can come in CSE also, and multiplexer is there as a part of your syllabus also, ABD. I'm planning one session I will take, maybe if I get time in the next week, one session I can take the PYQs of CSE. So CSE must attend, but all ECW should also attend, because interestingly there are very good questions in computer science also. Okay, very good questions in computer science, especially from the Boolean and logic gates part. Really good questions are there, and the sequential also. Okay, so I'm planning that next week, somewhere if I get time, I'll plan the PYQs of digital of computer science. And I request ECW, you should also attend that, because you're going to get a lot of benefit. Okay, leke aayenge. Anyways, ABD for CSE, other subjects to I, right? Digital I'll take for CSE also. Okay, so similar question, guys. That's what 100% अगर आपने 2016 का क्वेश्चन सॉल्व किया है, blindly you can solve this question. Blindly मतलब little bit, 1 minute of it will be there, but you can solve it up. गारंटी हो जाएगा. The propagation delay of the XOR AND gate and multiplexer, the XOR gate and the multiplexer in the circuit are 4, 2 and 1 respectively. If all the inputs PQ, RST are applied simultaneously, that is at the same instant, and held constant after that, what is the maximum propagation delay of the circuit? What is the maximum propagation delay of the circuit? Okay? Maximum propagation delay of the circuit. Okay? Chalo. Yeah. Well, if required, I'll bring for instrumentation also. Okay, I'll bring for instrumentation also, don't worry. If the bandwidth allows, I'll try to bring it for IN also, common subjects. Chalo. Okay, now let's come back. Okay, let's come and have a look into here and decide the answer. This is PQRST. This is the PQRST. All are applied at the same instant. Let us take the first case where T is 0 because T is the select line. Now, why T is important here? Okay, our state diagram pe questions are there. Let's go to the sequential. We will solve flip-flop, counters, state diagram, FSM questions. We are doing that. Huh? We'll do all things, Manish. Very important, very good questions are there. Ab dhyan dena. Why the select line is important? Because what is the flow from input to output? What is the flow from input to output? That will determine the propagation delay. But the flow from input to output will depend ki what multiplexer input is active. So if the select line S0 is 0, T equal to 0, so this is going to be active and this is going to be active. I0 input is active. Now, that means what path is crucial? AND gate ka delay hai 2, right? This has a delay 2, XOR delay 4, XOR delay 4 and multiplexer delay 1. Multiplexer delay 1. Okay, these are the delays given. Okay, what is the path for you? The path of the variable, okay, this goes here. That's it. Okay, yeah. Hey, do you need this? Do you even need this? This is not going to be selected. So you don't have to wait for this. So what is the time for the output to be produced by this AND gate is 2. Right, here multiplexer delay 2 plus 1, 3 nanoseconds. 3 nanoseconds is the delay here. Right, 3 nanoseconds is the delay here. 3 nanoseconds. But T can be 1 also, no? So for both the case we have to solve. So dear, if the T is equal to 1, so I1 will be active and here also I1 will be active. Let me write down the delays once again. Now look into the path. What is going to be the path? What is going to be the path now? Now I1 is active and that is why these two signals come here. This passes here. This gets applied here. Okay, now this goes to the AND gate, so I need the second input of the AND gate. So this also is active. This comes here. Okay, and then this passes through the output. Okay, so here the time taken is 2. Just a second. I think it has stuck. Yeah, this is 2. But here the signal is going to pass through this AND gate also, that is 2. Here it will take the time 2 plus 1 more of multiplexer, that is 3. This was ready at 2, but we have to wait for the last one. Now here the signal will be produced at 3 plus 2, which is 5, and 1 more unit delay of the multiplexer. So here it will going to be 5 plus 1, that is 6 nanoseconds, right? Okay, so what's your answer? The maximum propagation delay, in the first case it is 3, in the second case it is 6. So your answer is of course 6 nanoseconds. Your answer is of course the 6 nanoseconds. Done? It is the 6 nanoseconds. It is the 6 nanoseconds. Option number A, perfect. Okay. Conceptually 100% copy of the 2016 question. Conceptually. Okay, only diagram is slightly changed. Next question here. All right, so we are here, guys, everybody. We are here for your most awaited topic: counter, flip-flop, sequential circuit, state diagrams, FSM implementation, sequence detector, सब कुछ आएगा आप. Okay, everything is going to be there. Everything is going to be there. A counter is constructed with 3D flip-flops. The input-output pairs are named D0 Q0, D1 Q1, D2 Q2. यहाँ पे आराम से एकदम समझते हुए चलेंगे, right? Where the subscript 0 denotes the least significant bit. The output sequence is designed to be gray code. So it's a gray code. It's just a gray code counter. Gray counter, we also call it as gray counter using D flip-flop. Okay, gray sequence is given. Even if gray sequence is not given, you should know, you should be able to design the gray code sequence, not memorizing it. Okay, gray codes are reflected codes. Okay, तो बना सकते हैं आप लोग. Okay, so this sequence is not required for me. Okay, note that the bits are listed in the Q2, Q0, Q1, Q0 format. Yes, MSB to LSB. The combinational logic expression for the input of the flip-flop D1. Okay, now excitation signal बनाएंगे ना इसके लिए excitation table. So what is the current state? Q2, Q1, Q0. What is going to be the next state? Q2 plus, Q1 plus, Q0 plus. Okay, so here I have a column, first of all, comprising of the, फिर आगे चलेंगे, first of all, including the current state of the counter and then writing down the next state of the counter. Now, dear, current state can be anything, na? 3-bit, all possibilities, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. This is not gray sequence. This is the all possibilities of the 3 bits, right? What is the gray sequence? Everybody, right? 2-bit gray sequence, 0, 0, 0, 1, 1, 1, 1, 0, right? How do you form the 3-bit gray sequence then? From the 2-bit everybody knows, I think. इतना तो मैं expect कर सकता हूँ. How do you form the 3-bit then? Okay, so it's a reflected code. It's a reflected code. Take the mirror image of the top 4 and convert to the bottom 4. So 1, 0, 1, 1, 0, 1, 0, 0. Third bit, MSB low for the first 4, MSB high for the next 4. ऊपर MSB 0, नीचे MSB 1. That is what is the reflected code. So now, if it is 0, 0, 0, next is 0, 0, 1. If it is 0, 0, 1, next is 0, 1, 1. Okay, if it is 0, 1, 0, ध्यान देना. Right, 0, 1, 0 के बाद directly 1, 1, 0. That is where you have to be very careful in designing this question. After 0, 1, 0, it is the 1, 1, 0. Right, after 0, 1, 1, it is 0, 1, 0. 1, 0, 0 के बाद, 1, 0, 0 के बाद, 0, 0, back to 0, 0. After the 1, 0, 1, sir, it is 1, 0, 0. After the 1, 1, 0, it is 1, 1, 1. And after 1, 1, 1, it is 1, 0, 1. After 1, 1, 1, it is the 1, 0, 1. That is the gray sequence, everybody. That is known as the gray sequence. And now, what is the value of the excitation signals? Excitation signals are the inputs to be applied to the D flip-flop. How you should excite the D flip-flop so that it becomes a gray code counter, and the inputs to the flip-flops are D2, D1 and D0. हालांकि आपको केवल D1 से मतलब है. You are concentrated on D1. The question is only for the expression of the D1. Okay, but still I'll just complete. कर ही रहे हैं तो just one more effort, one more क्या, very small effort we can complete all, because for a D flip-flop na, everybody knows that for a D flip-flop, what is the next state equation? For a D flip-flop, Q plus is given by D. Q plus is given by D. Right? Q plus is given by D. अरे भाई साहब, तो अगर Q1 plus 0 है, so D1 plus has to be 0, then only you will get that. Reverse ideology you have to apply. What should be the D input to get the next state Q plus, right? So next state Q plus is 0, so here D has to be 0. How you have to excite the flip-flop, यही तो रखना है. So it has to be excited with 0. If the next state desired is 1, here you have to write down 1. So that means, अब इतना समझा दिया बहुत है, कॉपी कर दीजिए इसको. Right, 0, 1, 1, 1, then 0, 0, 1, 0. Similarly, copy the D2. Right, copy the D2 as the Q2 plus, so 0, 0, 1, 0, okay, 0, 1, 1, 1. Similarly, D0 will be copy of Q0 plus, so 1, 1, 0, 0, 0, 0, 1, 1, finish. Now we have to get the expression for D1. We have to get the expression for D1, right? What is D1 equal to? Okay, so K-map से ही तो बनाएंगे. D1 as a function of Q2, Q1, Q0. MSB to LSB लिखा. So this becomes the region Q2. This is known as the Q1. This is known as the Q0. If you have other habit of solving K-map, other way, you can solve that as well. Now Q2 is high when? 0, then 1, 1. This is 0, then 1, 1, 1. Next is 0 0 1 0 0 0 1 0. Usually I don't write down 0, not required. No? We have to only do the grouping of 1. Okay, so now it's a clear pairing. This is a horizontal pair, this becomes a vertical pair, there is no quad. What is this vertical pair? This is clearly within Q1 and outside Q0. Q0 bar ho gaya, and this one is above Q2, Q2 bar, and inside Q0, Q0, Q2 bar, Q0, Q2 bar, Q0, right? Q2 bar, Q0 plus Q1, Q0 bar. It is the option number D which totally matches. Okay. Okay. You can use your own as well, Ravi, right now. Let's not go into that. If you have already a habit, then follow that. No need to change that. Because K-maps pe aisa kuch nahi ki we have to discuss a lot here. Okay, guys, this is done. This is done. Just a moment. Chalo, done. Question is very simple, Tarun. You have to design a gray code counter, a counter which counts these sequence using D flip-flop, right? What should be the D inputs? Because they have to make a MCQ question, so they've asked only D1. Okay, if it was a conventional question, they can ask all three, tell the all three D1, D2, D2, D1, D0 and design the hardware, do the logic implementation of it. ठीक है, अभी बहुत सारे क्वेश्चन है, otherwise I could have completed this. ठीक है, ये तो हो गया. See, what is the D1? It is given by the Q2 bar Q0 plus Q1 Q0 bar. Let me give you additional homework, right? What should be the D2? What should be the D0? And then draw the complete hardware. Draw the complete hardware using, you know, whatever function you are getting using, then use the AND OR gates and draw the hardware of it. Okay, draw the hardware of it. कर सकते हो easily. Okay, do this up as an interest. 1 more minute. इतना कर लिया ना, just 1 more minute maybe. But let's go ahead because we have other questions to be discussed as well. In the circuit shown, the clock frequency, that is the frequency of the clock signal is 12 kilohertz. What is the frequency of the signal at Q2? Frequency division cases. What is the frequency of the signal at Q2? Hey, this has to be how much? The frequency at Q2. If you want, you can assume Q2 as MSB or even LSB also doesn't matter because we need the mod number. Okay, so whether you arrange Q1, Q2 or Q2, Q1, mod number of the counter will be same. Count sequence can change according to MSB, but mod number same rahega. So what is the frequency at Q2? It is given by the formula clock frequency divided by N. Divided by N, where N is equal to the mod number. What is the meaning of mod? Mod number या modulus? Okay, that means the total number of valid states which the counter is rotating, is going through. Okay, it is going through. So see, whether it is synchronous or ripple counter, Ashish, the role is to count a specific sequence, maybe binary sequence, maybe gray sequence, maybe prime number sequence, anything. The role is to count. Only thing is synchronous counters are more faster, little bit costlier. Ripple counters are slower but requires less hardware. Okay, अभी एक ripple counter के speed पे question भी आएगा, है ना? Just wait into that. चलो. So this is clock frequency divided by total number of states. So sir, what can be the total number of states here? Okay, so write down any specific sequence, Q1, Q2 or Q2, Q1 doesn't matter. But the important point is analyzing the circuit. So dear, what is the Q2 actually? What is the next state Q2? It is D2 and that is equal to Q1. So this is like a shift operation. This is like a shift operation. Whatever is the current state of Q1 will be transferred to the next state of Q2. Okay, and D flip-flops cascaded make shift registers, na? Okay, now this is not ring counter na. Okay, this is not the ring counter. अब ये देखो यहाँ पे, what is this? What is the Q1 plus next state is equal to D1. But what is D1? तो ये connection जो आया है, ये आया है Q1 bar. Another one is the Q2 bar. Okay, so this is Q1 bar, Q2 bar, or I can say Q1 plus Q2 whole bar, NOR gate. So this is like Q1 plus Q2 whole bar, NOR of Q1, Q2. Okay, so this has to be known, and we usually call this as the serial input. Okay, we usually call this as the serial input. Okay, that is going to this shift register. Okay, so for every value, let us start with 0, 0 automatically by default, and let me also write down the serial input for every combination. Serial input 0, 0 ka NOR is 1, 0 plus 0 is 0, complement leke 1, and then do the right shift here. 0 is transferred right. Whatever is the current value of Q1 goes to the next value of Q2. So that is why it goes to the next value of Q2, right? And then the serial input comes here. Q1 plus is equal to serial input. Now, what is the NOR of 1, 0? 1 plus 0 is 1. After taking NOR, it is 0. Then do the right shift. That's it. Okay. 0, 1 NOR. 0 plus 1 is 1. After taking complement, it is 0. Then do the right shift. And then it is repeated. And then it repeats. Right? How many number of states? 0, 0, 1, 0, 0, 1, 3. भाई ये तो repeat हो गया. By chance don't count this, okay? N is equal to 3. Don't count that repeated one. Acha, N is equal to 3. So what is going to be my answer? My answer is clock frequency given है 12 kilohertz divided by 3. So your answer is the 4 kilohertz, everybody. 4 kilohertz. Kilohertz is already given in the unit. So you have to fill only the numerical value 4. Numerical value 4, right? If it is the complete ripple counter ABD, then it will count 2 power n states, right? Divide frequency counters can be used as frequency division circuit, Ashish. Okay, they can be used as the frequency division circuit. Synchronous counter hai, so slight delay has to be there because of the gates involved. Okay, ripple counter will not involve the delay of the gates, Ashish. Chalo, this is done. Next question ki taraf move karte hai. This is a simple question, but EC 2019 1 mark. Next aate. EE 2018 2 marks. EE 2018 2 marks. Come on, everybody. Which one of the following statement is true about the digital circuit shown in the figure? About the digital circuit shown in the figure. It can be used for dividing the frequency by this, or it cannot be reliably used as frequency divider. Let's do the analysis of this circuit. Okay, let me call this as the output Q1. Let's call it as Q0, Q1, Q2. Output है ना, इसको MS भी बोल देते हैं, or any other. You can reverse the sequence also. You can reverse the sequence also, right? So I'm taking it as Q0, Q1, Q2. Okay, doesn't matter. Okay, and then let me call this as the serial input again as the last question. Okay, so what is the serial input here? What is the serial input here? This time it is the NAND of Q1, Q2. Q1 into Q2 whole NAND. Okay, because this one is the Q1, this one is the Q2. Acha, one more thing, rest you all know. What is the Q2 plus? Q2 plus is equal to D2, and that is coming from Q1. Ye yahan pe gaya, right? Similarly, what is the Q1 plus? What is the Q1 plus? It should be D1, and what is coming to the D1? It is the Q0. It is the Q0. It's like a regular shift operation only. Okay, I'll write down the serial input, which is the NAND of Q1, Q2. Iska NAND karna hai, right? 0, 0, 0 will start by default. Nothing is mentioned, so will automatically by default start with 0, 0, 0, right? And serial input 0, 0 ka NAND is 1. Okay, now guys, this is right shifted, this is right shifted, and serial input comes in. Now every time I will not show you the arrows, okay? Now 0, 0 ka NAND is still 1. Now this 1 comes here, 1, 0 right shifted. Then 1, 0 ka NAND is going to be 1 again. Okay, so then this is 1, 1, and 1 comes again. 1 into 1 ka NAND is 0. So 0, 1, 1. Okay, first 3 bits ko keval aage kar dena, including the serial input. Okay, now 1 into 1 NAND is again 0, right? 0, 0, 1. 0, 1 ka NAND is 1. Right, 0, 1 ka NAND is 1. Now this becomes 1, this becomes 0, 0. Now here I get a repetition. It does not go to the 0, 0, 0. So it will not be in the count sequence. Okay, it will not be in the count sequence. It is 1, 0, 0. It's going to be 1, 0, 0. Okay, it's going to be 1, 0, 0. Right, it's going to be 1, 0, 0. So what is the mod number now? 1, 2, 3, 4, 5. This is repeated. Okay, this is repeated. So these are the unique states. These are the unique states. So it is 5. So it can be used as a frequency divider circuit, dividing the frequency by 5. Dividing the frequency by 5. Correct? Dividing the frequency by 5. Okay. Not by one circuit, by cascading it can be achieved. Little bit, logic you have to apply for that, Ashish. Okay. एक twisted सा logic होगा. Come on, so this is mod 5 and it can be used for dividing the input frequency by 5. Next question चलते हैं. EC 2022 2 marks. EC 2022 2 marks. EC 2022 2 marks. Come on. EC 2022. You can search by my name Deepak, or I'll just share you the link of the Telegram. Everybody solve this question. Again, a good question. EC 2022, good question here. So, guys, whatever questions we are discussing, with the questions, with the solution that we are discussing, I will share you the PDF also. I will share you the PDF in the Telegram. I will share you the PDF in my Telegram. Right? I'll share you the PDF in my Telegram. But the PDF is going to be password protected. The PDF is going to be password protected. What is the password? Right now, I also don't know. Randomly, I will give you the password sometime, and that is going to be the password to access the PDF. So PDF will be password protected. Okay? So for the circuit shown, the clock frequency is F0 and the duty cycle is 25%. For the signal at the Q output of the flip-flop, okay, what is the correct option? For the signal at the Q output of the flip-flop. Good question. Cascading of the counter and the flip-flop. Cascading of the counter and the flip-flop. Okay, where the LSB bit of the counter, LSB bit, suppose that is the Q0, okay, goes to the J and K inputs of the flip-flop. Both the J and K inputs are commonly tied. So it behaves like a T flip-flop eventually. It behaves like a T flip-flop. Eventually T flip-flop जैसा होगा वो ये ध्यान रखना. Correct? Okay, चलो. Now let's have a look into it. Let's have a look into it. पहले हम ये समझ लेते हैं कि ये चलेगा कैसे. Okay, so what is the Q1 Q0? What is the Q1 Q0? It can be 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1 back to 0 0. That's what is a 2-bit regular up counter, 2-bit binary up counter. Okay, nothing mentioned, so I can take it as up also. So if you look into the LSB, every clock it just keeps switching 0 to 1 1 to 0 0 to 1 1 to 0, and this LSB applied to the JK input. Okay, let's assume that the output Q is 0 initially. Mentioned nahi hai, but we can assume. Okay, let's assume the output is 0 initially, and we have to select what is happening at the output, where the clock frequency is F0 and the duty cycle is 25%. So let me draw that clock waveform actually. First, let us take a reference clock waveform. The circuit is positive edge triggered. Yes, the circuit is positive edge triggered. Okay, but the clock duty cycle is 25%. Is it going to affect something or not? Let's have a look into it. Now everybody, this is what is known as the time period of the clock, right? And this is known as the on time period of the clock, which is 1/4 of the clock period of the time, because 1/4 itself is known as 25%, and duty cycle given hai 25%. The duty cycle is the 25%, right? Duty cycle is the 25%. ठीक है? 25%. Acha. Okay. Now, let me also mark the positive edges of the clock, because the circuit, as I told you, is the positive edge triggered circuit. ठीक है. अब पहले मैं LSB का वेवफॉर्म भी यहाँ पे मेंशन करूंगा. Let me also draw the LSB waveform Q0. LSB waveform Q0. Okay, which can be initially 0. Okay, then at every clock it changes. It becomes 1, then it becomes 0, then it becomes 1, then it becomes, अरे थोड़ा सा इसको correlate करते चलेंगे, then it drops here, 1, 0, 1, and etc. Right? 0, then it toggles to 1, then 0, then 1, then 0, then 1. This is the pattern of the LSB, na? LSB toggles at every clock. Now, the LSB is the input to the JK flip-flop. This is the input to the JK flip-flop. Acha. Now, JK flip-flop output is actually the Q. Okay, and Q मैंने क्या बोला? Let's assume Q is 0 initially. Right? At the clock edge. Now, what is the Q0 input? This Q0 input is the input to the JK flip-flop. Okay, at the clock edge. Actually, अब अगर really बात करें, practically बात करें, okay. Yeah, Veshu, that is also going on on our civil mechanical YouTube gate channel. That also you can search. BYJU'S exam prep, civil mechanical. अब देखो, before this clock edge, what is the input? Ideally छोड़ दे. Practically, what is the input that it is going to accept? Okay, it will accept the input that is just ready before the clock edge. So before the clock edge, it accepts the input 0, and 0 input means no change. 0 input means no change. Now at this clock edge, the input is 1. So there is going to be a change. Okay. And the change is toggle. Right. कौन सा input लिया? T input 1 लिया. So it toggles. Here, what is the input? 0. Here, if the input is 0, मैं correlate कर देता हूँ. I'll here take the input 0. I am here taking the input 1. I am here taking the input that is 0. Right. Similarly, here I'll take the input which is 1. Here I'll take the input which is 0. Now ध्यान देना. Okay, so here the input is 0, that is why no change. Keep moving, keep moving. Right. Here the input is 1, so toggle. Okay, now here the input is 0. Here the input is 0, so no change. Keep moving, keep moving, keep moving. But when the next clock edge comes, na, इसको भी show कर देते हैं. Right. When the next clock edge is coming, so this is going to now accept the input which is 1, and because of that there is again going to be a toggle here. Now look into the output waveform. Right. Now look into this output waveform. Very clearly, let's look into this repetition actually. Okay, this is the first positive transition, this is the next positive transition, and how many clock time periods are involved here? Let us say this is the time period of the Q waveform, and this is 1, 2, 3, 4. How many time periods? How many clock cycles? 4 clock cycles are involved, and this TQ can be written as 4T clock. So this TQ can be written as the 4T clock. This TQ can be written as the 4T clock. Done hai? I am writing it as 4T clock. Ye bhi done ho gaya. This is 4T clock. Okay. This is 4T clock. So what is the frequency at Q? It is 1 by 4 the clock frequency. Hey, reciprocal करेंगे time पर. Frequency is reciprocal of the clock frequency, or 1 by frequency F0. अच्छा, what is the on time period? What is the on time period? It is on for 2T clock. The total time period is 4T clock. It is on for 2T clock. So how much duty cycle? How much is the duty cycle? 50% duty cycle. So the frequency is F0 by 4 आया ना? Correct. And the duty cycle is 50%. The duty cycle is the 50%. Good question. EC 2022 2 marks. Good question. Okay, current year 2022 2 marks. Good question. Done. The frequency is F0 by 4 and the duty cycle is the 50%. 50%. Chalo, done. Done. Let's move ahead then. Okay. Let's move ahead then. Next question, guys. Let us move ahead to the next question. Okay, so good question. Very simple. EE 2022 1 mark. Actually, very simple question. This is the very simple question. Sir, very simple. When a mod 2 and mod 5 up counter, when cascaded together, results in a mod dash counter. When two counters are cascaded. When two counters are cascaded, mod numbers are multiplied. Mod numbers are multiplied. Okay, so your answer, it is 2 multiplied by 5 and that is going to be 10. Very, very simple question, sir. It is a mod 10 counter. This is going to behave as a mod 10 counter. Next question. The maximum clock frequency in megahertz of a 4-stage ripple counter utilizing flip-flops, with each flip-flop having a propagation delay of 20. What is the formula? What is the formula? Okay, for ripple counter. What is the formula for ripple counter? See, the formula for ripple counter. देखो, सबसे पहले let me write down the formula that the total propagation delay, the total, not of a single flip-flop, the total propagation delay of ripple counter is actually given by NTPD, right? NTPD, yeah, N T clock to Q, right? Where T clock to Q is the delay of one flip-flop. Is the delay of one flip-flop, right? So what is the minimum clock time period that can be designed? I'm just giving the final conclusion. Yes, I have explained you earlier. Okay, so minimum is equal to N T clock to Q, and that is why the maximum clock frequency is 1 over minimum time period, and that is given by 1 by N T clock to Q. Right. So here your answer is a straightforward. That is why it is a 1 marker expected type of question. It is a 4-bit, to N ka value 4 and T clock to Q for a flip-flop is given to you as 20 nanoseconds. That's it. Okay. So this is equal to 10 raised to the power minus 9 goes above 10 power 9, but I have to answer in megahertz. So I will break 10 power 3 into 10 power 6 is divided by 4 into 20, that is 80. Okay, so 0 bhi cancel hua, so 100 by 8 should be 12.5. And 10 power 6 I will convert into mega. So 12.5 megahertz should be the answer, dear. 12.5 megahertz, right? And that's what I told you, not very simply and directly. Okay, time basta hai, end mein to main Ashish batata hu aapko. I told you, you have to apply some logic to get into that, Ashish. Okay. 12.5 megahertz is the answer. 12.5 megahertz is the answer. 12.5 megahertz is the answer, dear. Okay. Chalo, badhiya. Okay. So let's do it up now. This is simple. Acha, by chance if it was synchronous counter, then? By chance if it was synchronous counter, then what will be your answer? If it is synchronous counter, then what will be your answer? Then the minimum time clock period has to be simply T clock to Q. There is no role of N here, and the maximum clock frequency is simply 1 upon T clock to Q. Okay. Then it is the direct. It is independent of the number of bits because it is a synchronous counter. All flip-flops works at the same time. Okay, and the total delay of the flip-flop is equal to the delay of one single flip-flop. So total delay of the counter, however the bits may be, it is equal to the delay of one flip-flop stage. Okay, done. Chalo, next question pe aate. That is why this is a 1 marker question, because we should know that. Okay, we should know these formulas directly. Next, W21 1 marker question again. This question requires just a simple understanding of numbers. It's not a counter question, you will understand. Okay. Yes, Ravi, decent. Branches, I think easy, na, Ravi? Chalo, tell me guys, next. A 16-bit synchronous binary up counter is clocked with the frequency F clock. The two most significant bits are odd together to form the output Y. Measurements show that Y is periodic and the duration for which Y remains high in each period is 24 milliseconds. What is the clock frequency F clock in megahertz? What is the clock frequency F clock? It purely requires, okay, double hai to decent hai, will improve. Of course, you have 1 month, okay, 1 month, 40 days, well, around 40 more days total. So it will definitely improve. Okay. तो थोड़ा बेटर होगा तो और अच्छा है। चलो डन। हाँ जी, so very simple question. It's not a counter, it's a number system type of question. It's a 16-bit counter. अच्छा, 16-bit counter will have the bits from Q15 up to Q0. Okay. Now, the two most significant bits, right? These are the two most significant bits. So, if you write down the count pattern, na, Q15, Q14, Q13, Q12, etc. up to Q1, Q0, you will feel that by starting to will be with zeros, na? Right. Next will be 0, 0, 0, 0, etc., etc., 0, 1. Right. Now, OR gate output is high. Okay. To form the output Y, यहाँ पे क्या बोला है? I am going to use the two most significant bits, that is the Q15 and the Q14. Going to OR them and give the output Y, and output of OR gate high if any one of the input is high. If both the inputs are 0, then the output will be 0, right? So for the first few combinations, right, ये तो 0 0 रहेगा, but how many of those combinations, right, up to the, इन दोनों को छोड़ के leave these two, what is the highest count here? 1 1 1 1 1 1 1 1 1, right? Now here comes the next count, which is going to be 0 1 0 1, then this becomes 0 0 0 0 0 0 0. So if I write down the output Y here, na, if I write down the output Y here, Y is 0, but from here Y starts becoming the 1. From here the Y starts becoming the 1. Okay, and then it will remain 1. See, this is 0 1, बहुत time तक ये 1 रहेगा, then this can also become 1. Sometimes this will be 1, sometimes this will be 1, sometimes both will be 1. So eventually it is going to be high only up to the last combination, which is 1 1 1 1 1 1. Till this time Y is going to be high. अच्छा, तो ध्यान रखना, what is this last combination? Last decimal value is always 2 power n minus 1, 2 power 16 minus 1, and how much is this value जिसको छोड़ के आए हैं? Now this is again all ones, but for 14 bits. All ones, suppose it is a 14-bit number, I can remove this. It's a 14-bit number. So what is that decimal value? This is going to be 2 की power 14 minus 1. So how many of these values are here? Right. Y equal to 1 for how many combinations? Right. Y equal to 1 for how many combinations? Dear, 2 power 16 minus 1 minus 2 power 14 minus 1. And this is going to be, let's calculate. So I can say that Y will be high for these many clock cycles. And what is the value of this? 1 to 1 cancelled. 1 to 1 cancel. This is 49152. 49152 clock cycles. Acha. Now measurements have given that Y is periodic, it will be periodic. After it is 1, after again, then it will start at 0. Y will be 0 1 0 1 0 1, and Y is equal to, question kahan gaya, sorry, where is that question? Y remains high in each period for 24 milliseconds. Matlab, okay, Y will be high for 49152 clock cycles. Okay, for 49152 clock cycles, that is why 49152 into T clock is equal to 24 millisecond. So what is the value of the T clock? What is the value of the T clock? And then they are actually asking the clock frequency. So invert this. So your answer will be 49152 divided by 24 into 10 raised to the power minus 3. Let's do this calculation. Right. So this is turning out to be 2048 into 10 power 3 goes above, and I need the answer in megahertz. Right. So 10 power 6 chahiye. So it has to be 2.048 into 10 power 6 hertz, or my answer is 2.048 megahertz. Good question, huh? Okay. You have to scan in my Telegram group only, Pranav. Okay, 2.048. This becomes 2.048. This becomes the 2.048, everybody. Right? 2.048 megahertz. Now, why it is 1 mark? Because this is expected that students should be very strong and very fast in the number system calculation. Okay, the number system calculations. This is what very basics you learn in number system. That is why I told you in a double E mein, directly you don't expect number system type questions, but indirectly it is there. Digital means you have to start with number system only. Okay, may double E don't have to practice much questions on number system. EC mein direct aa jata hai. For EC you can have the direct number system question. That too not very frequent, but yeah, there are direct questions in EC. Double E direct questions you don't find, but indirectly you know you need to know these calculations. If you are good enough in this already, then no problem. Okay, chalo. Let's move ahead. Old one it is, Pranav, old, long time back. Next one aa jate hain guys. Now it's a good question. EC 2021 2 marks. Ye good question aaya. Thoda, you know, 2 or 3 very good questions will also be there. Hai? Don't worry. Let us see all. All means all. Tension nahi lenge na. All means all. Okay. So propagation delay of the exclusive OR gate in the circuit in the figure is 3. Okay. So delay of this OR gate, exclusive OR gate, XOR gate is 3. The propagation delay of all the flip-flops is assumed to be 0. Okay, the delay of the flip-flop is assumed. It's just a hypothetical question. It cannot be the case that XOR gate delays 3 and flip-flops has 0. Flip-flops will have even a little bit more delay if XOR data is 3. But assume karna hai. Ek design question diya IIT ne. Now the clock frequency provided to the circuit is 500 megahertz. Starting from the initial value of the flip-flop outputs Q2, Q1, Q0 equal to 111 with D2 equal to 1. What is the minimum number of triggering clock edges after which the flip-flop outputs Q2, Q1, Q0 becomes 100? Becomes 100. Becomes 100. Dhyan dena. Becomes the 100. Everybody. Becomes the 100. Okay, chalo. So let's have a look into this circuit. This is again, you are all able to understand it's a shift register case. Okay, this will be written as serial input, and we know that Q0 plus is equal to D0, but that is eventually equal to the Q1. Okay, so Q1 value is shifted here, right? Similarly, just a moment. Now it is ready. Similarly, Q1 plus is equal to D1 is equal to Q2. Okay, the Q2 value is shifted here. And then what is the Q2 plus is equal to D2, and that is equal to the serial input. And what is the serial input? It is the XOR of Q2 and Q0, MSB and LSB. It is the XOR of Q2, Q0, that is the MSB and the LSB. Okay. Chalo. Next. Q2 and Q0 next. अब क्या करेंगे यहाँ पे? Okay, now let me write down the count sequence. Q2, Q1, Q0, Q2, Q1, Q0, and the serial input. Everybody, serial input Q2, Q1, and Q0. Okay, and initial value जो given है आपको, now initially they have given 111 and D2, that is the serial input is also 1. Initially this is 111 and this is also 1. There is no delay of the flip-flop, but there is the clock cycle. How much is the clock time period? Okay, so यहाँ से निकाल लेंगे. Clock frequency is 500 megahertz. So what is the time period of the clock is 1 upon 500 10 power minus 6. So this can become 0.52. This can become 2 nanoseconds, correct? 1 upon 0.5 10 power minus 10, correct? 2 nanoseconds. Okay, this is known as 2 nanoseconds. So time period is 2 nanoseconds. So after every clock we find transition, but that clock will come after 2 nanoseconds. Yeah, very interesting question hai. So we know that next, this is ready. Now it's a shift register case where the Q2 is shifted here, Q1 is shifted here, and whatever is the serial input comes to the MSB. It's a shift register case only. Okay, so these two bits these two bits are shifted forward and serial input makes an entry here. So this will happen at t equal to 2 nanoseconds. ये तो given है initially. This is also given initially. Okay. But this state will occur 2 nanoseconds. Now, dear, very important point to notice that serial input, let me write down its value, its formula. The serial input is actually the XOR of the MSB and LSB. Yahi given hai na? It is the XOR of the MSB and LSB. This is known as the XOR of MSB LSB. 1 and 1 ka XOR is 0. XOR of 1 and 1 is 0. But the important point here is that the delay of XOR gate is 3 nanoseconds. Okay, this is ready, but XOR gate will produce the output at t equal to 3 nanoseconds. That means this is the input not to be accepted right now. Okay, now 2 nanoseconds, next clock edge come, and next transition. Next transition matlab these two to be right shifted and yahan se isko copy lena hai. Everybody, yahan se isko copy lena hai. So next state is again 1 1 1. Is that okay, everybody? Next state is still 1 1 1. It is still 1 1 1 because this is not yet arrived. 2 nanosecond where one state change occurs, but this is not yet arrived. This will occur after some time. Okay, so the next possibility is 1 1 1. Then let us come next. Okay, acha. Now this will come at 3 nanoseconds and this is happening at t equal to 4. This is coming at 4 nanoseconds. Okay, this is coming at 4 nanoseconds. So what is going now? Now this is ready. So definitely now the next state is going to be this is right shifted, and the 0. This is now ready, will come up here. ठीक है. अच्छा, this 1 and 1 का XOR again 0. ठीक है, but exactly यहां ध्यान देना, exactly this will come at देखो पहले this happened, this is the input corresponding to these two. Okay, this arrived here. Okay, and then we have these two and इसका XOR यहाँ पे आएगा corresponding to the t equal to the 6 nanoseconds. This will be corresponding to the t equal to 6 nanoseconds. XOR delay is again 3 more nanoseconds. Okay, now this matches. तो यहाँ पे जो है ना, correct. Now यहाँ पे this also arrived at t equal to 6 nanoseconds. Okay, t equal to 6 nanosecond. But then 1 and 1 XOR will again be 0. ये तो इन दोनों का XOR यहाँ आ गया था. Just wait a moment. Okay, then 1 and 1 का XOR, this arrives at 6 nanosecond. Okay, but 6 nanosecond पे state changes. तो 0 1 का XOR will come 0 again. 0 1 का XOR will be 1, but this will come at 9 nanoseconds. ये जाएगा 9 nanoseconds पे. Okay. So your next transition of the state will be 0 0 1. Okay. And then this already comes at 8 nanoseconds. ये हो जाएगा 8 nanoseconds पे. Okay. We have to still wait for it. That is going to come at 9. Okay. That is going to come at 9 0 0. And now this I will copy it. Okay. Because in between 9 is going and 1 0 0. And I think this is what is the question. The 1 0 0 comes when? Okay. So when you write down on your own, then I think there's a little twisted timing here, timing there. Okay, but if you write down on your own copy, I've given you hints how to solve it up. And this is coming after 1, 2. ये तो initial था 3, 4, 5. After 5. After कितना? 5 nanoseconds, correct? This is going to come after 5 nanoseconds. After 5 clock cycles, After 5 clock cycles. Okay, the number of clock edges, the number of clock cycles. ठीक है, 5. Good question. Try to write down this once again on your own. You'll get a better idea. Okay. Get a better idea once you step by step write down. Okay, but this is the procedure of solving this question. So your correct answer is 5. 5 clock edges will be required. And let's move ahead to the next question. Very good question. 2018 2 marks. There was a very good question. Let me tell you very honestly, I'm finding that last 5 years, whether it is 2018 or like previous question is 2021, we have seen 22 good questions. MSQ pucha 2020 also good questions. So guys, last 5 years sequential circuit has produced good question, not only in terms of weightage but in terms of level. Really conceptual question where you need to apply good logic, good concept, usually toppers type of question. Next, in the circuit below, a positive edge trigger D flip-flop is used to sample the data input D in using the clock CK. Okay, this is the clock CK. I think it is hidden here. Isko upar karte hain. This is mentioned here. Yahan pe bhi hai, using the clock CK. Okay, the XOR gate outputs 3.3 for logic high and 0 for logic low. The data bit and clock periods are equal and the value delta T by TCK is equal to 0.15, where the parameters delta T and TCK are as shown in the figure. Assume that flip-flop and XOR gates are ideal if the probability of the data input transition in each clock pulse. But ये जो data input है ना, it may show a transition, it may not show a transition, because this question they have linked with the probability. They have linked with the probability. So if the probability of data input transition in each clock period is 0.3, what is the average value accurate to 2 decimal places of the voltage at the node X? Of the voltage at the node X. Shared few moments back only, Vaibhav. You can check that in the chat box. Okay, देखो इसको समझते हैं. Let's have a look into this. See guys, what is this X? This X is actually XOR, okay, of the Q and D in. It is the XOR of the Q and D in, right? Okay, it is the XOR of Q and D in. Okay, now D in, यहाँ पे क्या बोला? If the probability of input data bit D in transition, okay, so D in may transit or may not transit. तो ध्यान देना, what about the D in waveform? Okay, what about the D in waveform? It may make a transition, it may not make a transition. I'll better uplift this and let us fill this with the same color, and now let us solve it. Okay, now let us solve this up. Okay, now there are two cases for the D in, everybody. There are two cases for the D in. Okay, D in may not make a transition. D in may not make a transition. Okay, suppose it starts with 0, it remains to be 0. And in that case, what is going to be the X? In that case, what is going to be the X? So X is what? Q XOR D in. What is going to be the Q then? What is the Q waveform in that case? Everybody, ye bhi dekh lete. What is the Q waveform in that case? What is the Q waveform? Q is just Q plus is just equal to D. And initially Q starts with 0. Again, a regular assumption. Okay, Q starts with 0 and it will just copy the D. There is no change in the D. So Q also remains to be 0. Okay, Q also remains to be 0. Okay, so this is also 0. This is the Q waveform. This is the D in waveform. Okay, and what is the XOR of these two then? What is the XOR of these two? Q XOR D in. What is the XOR? What is going to be the XOR? 0 XOR 0. Right? 0 XOR 0, 0. And it is throughout 0. It is just throughout 0. X, which is Q XOR D, it is simply 0 XOR 0 throughout, and same pe XOR output will be 0. This is one instance. Okay. Now, this event will happen with the probability of 0.7, because kya bola tha? D in will make a transition with the probability 0.3, so it will not make a transition with probability 0.7. It will not make a transition with the probability 0.7. Okay, now इसी को copy करेंगे. I need this diagram for one more time. Just a moment, है ना? Let me copy the same thing. चलो, done आ गया? Yeah. Now from here, I will remove this. Oh, sorry. What has happened to this guy? Now this is okay. Okay, so this is one case. Now next situation, I will assume that D in makes the transition, right? And if it is making a transition, it is making a, let me assume the ideal transition. Okay, here it makes a transition in this clock cycle. I don't know about next, but here at least it makes a transition. Here at least it makes a transition. Okay, now if this is D in, it was 0, now it becomes 1. What about the Q output? Q is given by 0. Q plus is given by D in, right? And it is a positive edge triggered connection. The question is positive edge triggered. You can note that. So this is positive edge. This is the next positive edge. Okay. So at the first positive edge there, what is the D input? 0. So Q will remain to be 0, and it will remain to be 0 at the next edge. But the next positive edge, at the next positive edge, we see the D input. Earlier it was 0. Now at this positive edge, D becomes 1. And because the D is 1, Q plus will again become D. Okay. Q plus will become D. Okay. So, and it will remain high at least for this much of the time. Iske baad ka I don't know. Again, and this next clock cycle, the D may make a transition, may not make a transition. Let us stop here. Up to this point. Okay, up to this point. Now, what about the X? X, which I have told you, it is Q XOR D in. So, in dono ka XOR karo, 0 initially, right? 0 XOR 0 is 0. But here, 1 XOR 0, this is still 0. 1 XOR 0 is 1. Different aa gaya na? Right? Different aa gaya. Here, 1 XOR 0. Sorry, this is 1 and 1. Again, same, 1 XOR 1. This is 0. Right? So, if I talk about one time period of the clock, everybody, very, very, very good question going on. Hai na? Now, from here to here is clock period, but I can say, bhai, between this delta t to delta t, this is also one clock period. Na? Hum to aisa le lete hain. Is that visible there? Perfect. Okay. So, from here to here, ये line से लेके ये line की बात कर रहा हूं. This is also 1 t clock, and out of which X is on for, by how much is this? Delta t. By delta t is 0.15. Question में given है 0.15 t. Right? And this will happen with the probability of 0.3, because D in makes a transition with the probability 0.3. Okay, D in makes the probability transition 0.3. ठीक है? Now, question में पूछा है, what is the average value of the voltage at the node X? Average value of X. Average value can also be calculated by just considering its area. Logic high means 1.1. तो ध्यान देना, right? If I consider the case of probability 0.7, D in makes no transition. D in mein there is no transition, and then what is the average value of X? What is the X? X is equal to 0. I have shown you in the first case, X is just a flat line 0, right? And if it is constantly 0 only, so what is the average value? It is 0. Okay. But the next case that happens with the probability of 0.3, there is a D in transition. There is a transition that happens at the D in. There is a D in transition. And in that case, what is the X? If you see the waveform of X, okay, if I convert into a complete analog voltage, because logic level 1 is 3.3. ये भी question में बोला है. Have a look into this. Okay. Where is that mentioned? 3.3 volts for logic high and 0 for logic low. So 3.3 volts. So the value of X in volts, the value of X in volts is going to be 3.3 is going to be 3.3. This is 3.3 volts up to how much of time? Okay, up to the total time period of the clock minus 0.15, that is 0.85. Okay, so this has to be, ये complete time period हो गया clock का. So this one is 0.85. 85% time. What is the average value? It is the area under the graph also. So we can write down its average value as height is multiplied by the base. Okay, height is multiplied by the base, that is 0.85 t clock. 0.85 t clock. करेक्ट है ना? टी क्लॉक की वैल्यू की नीड भी नहीं है, दैट्स ओके, राइट. सो द एवरेज वैल्यू इज दिस मच. ओके, 3.3 into 0.5 t clock. Okay, so what is the final average value? What is the final weighted average value? Total probability theorem apply करके the average value is 0 with the probability 0.7 and the average value is given by 3.3 into 0.85 with the probability of 0.3. Okay, the first part is 0, just multiply the rest two and get the answer. When I multiply this, 0.3, this is 0.8415. 0.8415 volts is the average value. This is the average value, 0.8415, right? The 0.8415, it's the answer. .8415. This is known as the 0.8415. Everybody, 0.8415. Done. .8415 volt. Done. Very extremely good question I can call, because it is a mixture of weighted probability. We also call it as total probability theorem, right? And with that probability, you have to draw two different waveforms. So waveform questions have been always important in this examination, correct? In this gate examination, especially from the digital, correct? 0.8415 volts, absolutely correct, guys. And this was a very good question sorted up. Okay, very good question sorted up. Moving ahead to the next. Okay, moving ahead to the next. Okay. Yeah, whoever is taking digital in the MMC solution will discuss that, Ravi. Okay. The state transition diagram for the circuit shown below. The state transition diagram for the circuit shown below is... Okay, now it's directly a transition, state diagram based question. Everybody focus here. State diagram based question. Okay. देखो, यहाँ पे ध्यान देखेंगे. Have a look into the circuit and we'll not look into the options. Directly we can draw the state diagram. It's a D flip-flop mixed with a multiplexer. Okay, and this is the input A. So what is the reference input? A. Okay, look into the state diagram. The arrows, the transitions are for what input? For the input A. Okay, so this is my input. Okay, and state transition diagram will store the state. State is for the flip-flop and this is the state that I'm talking about. So guys, what is the Q plus? Q plus is given by D for a D flip-flop, right? But D is getting the output of the NAND gate. What is the output of the NAND gate? It is Q into, so this is itself Q, and the another one, suppose it is the output of multiplexer. Suppose this is Y. Suppose this is Y. This was X. This is X into Q and then whole bar. X into Q whole bar. Now X into Y whole bar. I'm sorry. This is Q into Y whole bar. Slip of tongue. Q into Y whole bar. Okay. It is the Q into Y whole bar. अच्छा जी. Q into Y whole bar. अब what is the value of Y? What is the value of Y? So Y को देखना पड़ेगा. Y will be equal to I naught. That is Q bar. यहाँ पे आया Q bar. Right. If the select line is 0. But if the select line is equal to 1. If the select line is 1, output will be Y. Output will be equal to Q, I1. multiplexer output will be I1 and that is equal to Q. That is equal to the Q. Okay, तो यहाँ पे substitute करेंगे and eventually I will get a final expression for Q plus. Right? So what is going to be the Q plus? Everybody. It is Y. It is Q into Y, and that is Q into Q bar ka whole bar if A is 0. It is Q into Y. Next case mein Y is equal to Q only. If the input is equal to 1, right? So eventually the final answer 0, 1, Q into Q bar 0, 0 complement 1. So if input is 0, next state is always 1, set state. Right? If the input is 1, Q into Q is Q whole bar leke Q bar aayega. So if the input is 1, it is going to toggle. So there are only two conditions in this. It's either going to set or it's either going to toggle the state. Okay, set or toggle. Okay, let me draw the state transition diagram. Q may be 0, Q may be 1. There are two states always for a flip-flop, set, reset or set. Whenever the input A is 0, it is always going to be in the same state. It's going to be in the set state, set. So 0 hai to bhi 1 mein jayega. If the input is what? If the input is 0. If it is set, it will remain set. It is already set, na? So transition to the same, moving to the same state if the input is 0. But if the input is 1, you have to toggle. If the input is 1, you have to toggle. Dekho. So if the input is 1, we can show another. But commonly, no need to show the another branch. You can write down the input here itself by placing a comma. Right? And if the input is 1, it will toggle from set also. From set, it will go to reset. If the input is 1, from reset it will go to 1. There is another way. Draw another arrow and write down A equal to 1. But no need. You can write down. You can use the same transition and write down the input by placing the comma with the first one. So the correct answer. See, here they have, this is the correct answer. I think D is the correct answer. A pe transition, 0 pe set. Correct. And here they have shown two arrows. Not required. This is also correct. But what I'm trying to say is not required. Look into this option number D. Here they have shown two arrows. Okay. For the same transition, but input different. This is also correct. This is also correct. But what I have done is I can place 0 and 1 comma. On the same transition, you can write down both the values of the input by placing a comma. The comma in the state diagram will mean that either the A is 0 or 1, there will be transition from the reset to the set state. From the reset to the set state, sir. Done, eh? Alright, so D is the correct answer. This is also a valid way, but the more effective way of usually drawing the state diagram is this one. Okay, but that is also correct. D is the correct answer. D is the correct answer. Before I am now going to take the next question, let me give you the PDF password. All the questions, 5 years question, EC plus EE combined that we have done till now and that we are going to do more questions will be shared in the PDF in my Telegram group. Telegram link was shared. I can just reshare it. Is already there. Na? Isko just take by press kar diya. Yeah. I have again shared the Telegram link. Okay, you can join this Telegram and get the access to the PDF. PDF will be password protected. Only the students watching the session now or later, whenever you are watching, you will get the PDF. The password is state. Just now we have discussed the state diagram question. So randomly I framed STATE all small. STATE all small. STATE all small. This is going to be the password. Let's move ahead to the next question. Okay. EE 2020 1 mark question. EE 2020 1 mark question. A sequence detector is designed to detect. Sequence detector question. Okay. Sequence detector question. It is designed to detect precisely 3 digital inputs with overlapping sequences detectable. Overlapping sequence detectable. Sequence detector with overlapping sequence. For the sequence 101, okay, and the input data. Achha, what is that input data? I need to write down that separately clearly. The input data is 1 1 0 1 0 0 1 1 0 1 0 1 1 0, sir. ठीक है जी? What is going to be the output for this detector? Acha, it's a 3. It needs 3 digital inputs. Okay. So for the first 3 inputs, have a look into this. What is the output? 110. Now output will be high when you get 101. When you get 101. अच्छा, what is the meaning of overlapping? ये बताता हूं मैं पहले. Overlapping means, see, one sequence ended here, another sequence started with that ending. 101 is the last one of the sequence. It is also the first one of another sequence. This is what is the overlapping meaning, right? Matlab, both the times output will be high. Okay, the last bit of the sequence can also be treated as the first bit of the upcoming sequence 101. That is what is overlapping. Okay, I hope you already know this. Now 110 output is 0. Okay, now next 3 bits. Well, next 3 bits मतलब ये दो तो common चलेगा ना, it's overlapping. So 110 is detected, output is low because I want 101 to be detected, right? Now एक एक करके चलेंगे. 101, yes, I get the output high. So it should start from 01. This is wrong. It should start from 01 to ABD. Okay, then ऊपर नीचे लिखते जाता हूं. Then let me take this 010 0. Then let's start here 100 0. Then अब किससे बचेगा? अब इससे स्टार्ट किया 001, आउटपुट इज 0. Then start with the next 011, आउटपुट इज 0. Then इससे चेक करेंगे 110, आउटपुट इज अगेन 0. Now next, the next 3 bits, the next immediate 3 bits 101, it is 1 now. Now next 010, it is 0. Now next 101, again 1. Now next 011 0. Now next, इसके बाद तो दिख ही नहीं रहा है, but still let me complete. 110 is 0, and then there are no 3-bit combinations. So your output has to be start from here. यहां से start करना, तो 01 count 01 0 0 0 0 0 5 zeros, right? 01. Let me see 1 2 3 4 5. Perfect. यहां पे क्या प्रॉब्लम है? 1 2 3 4 5 6. No. 1 2 3 4 5. ये भी ठीक है, ठीक है, ये भी ठीक है. Now there comes a 1. Now there comes a 1. Then 0100. There comes a 1. 0100. Here also comes a 1. 0110. D is wrong. A is what perfectly matching. A is what is perfectly matching with our calculations. Right. इसको भी शो कर देते हैं. कोई बात नहीं. A is the correct answer. What is this यार? It is just a puzzle. इसमें तो कुछ भी नहीं है. They have not asked you to design the sequence detector. You can design the 101 sequence detector, right? You should study that. FSM, sequence detectors, important topic in the recent years. Okay, let's move ahead to the next. Let us move ahead to the next. EC 2020 2 marks question. It is a bonus for 2 marks because if they ask you to design, it takes slight effort. That do very minimum. If they ask you, especially if they ask you to design the state diagram, it is very simple. Okay, 2 marks के लिए simple है, थोड़ा time लगेगा. But here they have given the state diagram. Tell me what sequence is detected. This is like, if you have studied the sequence detector once also, it is a very simple question. Of course, guys, unfortunately, we are not discussing the sequence detector in detail here, right? कभी required होगा तो I can plan an extra session because this is all PYQ. So I'll just talk about the crisp solution of this. Okay. How to design sequence detector? If you want, let me know. We can plan sometime else. So the state diagrams of a sequence detector is given below. S0 is the initial state. What is if the output is 1, then what sequence is detected? देखो, the simple philosophy in the sequence detector. When do you go to the next state? When a particular bit of the entire sequence is detected. When a particular bit of the entire sequence is detected. So when I am going next, when the input is 0. Acha, in the state diagram, what is this slash? Right, it is in/out. The first bit represents the input / the output. Okay, so 1 आएगा तो I remain in the same state. मतलब I don't want 1. Okay, I want 0. Okay, if 0 is detected, if 0 is detected, I will go next. Then next state में, if 0 is detected, I will remain to be same. That means I don't want 0. But if 1 is detected. If 1 is detected, I go next, advanced. Okay. Then in the next state S2, right? If 1 is detected, I go back to the reset. Everything is lost. That means I don't want 1. But if 0 is detected, I go to the next advancing stage. S3 तक आ गए. So 0, 1, 0. Next, after S3, again if you detect 0, you come back to one of the previous state. मतलब you have not gone into any new advanced state. So this is not I want. But if I detect 1, I go to a new state S4. So 0, 1, 0, 1. On to the S4. On to the S4. If I get 1, I reset the machine. Matlab, everything is lost. I go to the initial reset state and the output is also 0. But If I detect 0, the output also becomes 1. Okay. So output 1 kab hua? What is the sequence to make the output 1? Okay. Did the bit 0, then 1, then 0, then 1, and then 0. If this sequence is completed 0, 1, 0, 1, 0, then the output is high. So this is detecting the sequence 0, 1, 0, 1, 0. But even for this question, this is a very simple laddu question for 2 marks. But for this question also, you must have studied state sequence detector once. Then only you can understand कि why I am moving forward. ये मैंने क्यों किया? It's not that I wish it. This is how we design the state sequence detectors. So once you study the sequence detector, the first thing that you do is you draw the state diagrams. This is not drawing state diagram may take little bit time, maybe 1 minute or so, but this is analyzing the state diagram. It can be solved in 20 seconds if you have studied this topic. अगर आपको ये topic आता है तो. Done है? Next question. Next question. Okay. EC 2020 2 marks MSQ question. See, possibly third MSQ question 2022 only from the digital electronics. Only from the digital electronics. Third MSQ question for 2 marks. Third MSQ question for 2 marks. Tell me. Third MSQ question for 2 marks. Come on, everybody. Come on, tell. Tell the answer, tell the answer, tell the answer. भाई ये बहुत सिंपल है. देखो, this now you may worry, अरे sir, state diagram mixed with probability. If you are clear with the logic, these are bonus questions for you. And that is what sometimes GATE test, graduate aptitude test in engineering, aptitude का question है. Aptitude का question है. The state transition diagram with the states ABC and transition probabilities P1 to P7 is shown in the figure. Okay. P1 denotes the probability of transition from state A to state B. For this state diagram, select the statement which are universally true, which is or are universally true. मतलब जो तो हर हाल में universally, why they are mentioning, because they have not told what this circuit is all about, whether it is a sequence detector, sequence generator, or some counter or any other thing. They have not told you. But be it any type of circuit, what relation of this probabilities is universally true, where P1 to P7 are the probability of transition from one state to another. Have a look into this. My dear, listen to the simple idea. If I am in some state, I will make some transition. I can be in the same state, or I can go to the next state, or I can go to some previous state, but I will make some transition. If I talk with respect to state A, ध्यान देना. If I talk with respect to state A, either I will remain in the same state, right? Hey, what is the list of all possibilities? Right, I can go from A to A, that means I remain in the same, or I can go from A to B, or I can go from A to C. A to A probability P7, A to B probability P1, A to C तो आ ही नहीं रहा है ना. There is no transition from A to C, so that probability is 0. Okay, A to B probability P1 है और A to A probability P7 है, and very simple idea says that P1 plus P7 sir should be 1. Correct है ना? कुछ मिस हुआ क्या? नहीं, A to C है तो सही. Sorry, I missed that. A to C है. There is A to C with the probability P4. Okay, so sum of all these, that is P1 plus the P4 plus the P7 is equal to 1, because that is what is sum of all probabilities always equal to 1. भाई अब यही चीज जब मैं स्टेट बी पे अप्लाई करूंगा, okay, state B, what is the list of all possibilities? What is the list of all possibility? Right, either I can go from B to A, either I can go from B to B, either I can go from B to C. Right, probability B to A probability P3, B to B probability P2, and B to C. There is no transition from B to C, the probability is 0, and sum of them, matlab P2 plus P3 will be 1. P2 plus P3 will be 1. P2 plus P3 will be 1. ठीक है. And here itself, let me talk about state C. What are all possibilities from the state C? It can be C to A, C to B, or C to C. C to A, P6. C to B, there is no transition from C to B, that is 0 probability. And C to C in the same state, P5. That means, this is the all possibilities, that means sum of P5 and P6 is equal to 1. Now match the options. P1 plus P4 plus P7 is 1, dear. P1 plus P4 plus P7 is 1. Okay. And then P2 plus P3 is 1. P5 plus P6 is 1. So I can say P2 plus P3 same as P5 plus P6. A be correct hai. A be correct hai. So option number A, option number C. P2 plus P3 is same as P5 plus C6 and both are equal to 1. Both are equal to 1. Eventually both are equal. Right. Now boliye, isn't it a simple question? But I will tell you, many students just by looking into the question, without even attempting, they will leave it. That is why this question becomes tough. Ye tough kyun bana? Because usually, whenever we see some random thing mixed, digital electronics, that too state diagram, okay, students are a little bit already worried about state diagram question, and that too mixed with probability. So thinking that, arey sir, this is nothing to do with digital. This is actually an aptitude question. It actually digital ka hi hai, but solution for an engineer, it's aptitude, basic aptitude. Okay. Maybe by looking into the question, you have an intention of leaving it, you lose 2 marks. But it is easy one for me. It is very easy one according to me. Ekdam easy hai ye. Right? One of the easy kind. Chalo, no problem. Let's move ahead. Let's take the next one. Okay, the time is 11. It's 11:07. Oh, it's 11:07. Chalo, quickly. Few more questions. A traffic signal cycles from green to yellow, yellow to red, red to green, and in each cycle, green is turned on for 70 seconds, yellow for 5 and red for 75. The traffic light has to be implemented using a finite state machine. So traffic signal designer. This traffic light has to be implemented using a finite state machine. The only input to this FSM is a clock of 5-second period. What is the minimum number of clock cycles required to implement this FSM? So they have not asked you to design FSM. Designing that FSM is simple again, but it's lengthy process, time taking. 1 mark mein to nahi hoga, 2 mark ke liye bhi nahi aayega. But the very logical question, minimum number of flip-flops required to implement. So a traffic signal cycles from green to yellow, yellow to red and red to green. Ye sequence hai. And in every cycle, green is on for 70, yellow as a buffer for 5 and red is on for 75. Okay, red is on for 75. Now, the only input to this is a clock of 5-second period. What is the time period of the clock given to you is 5 seconds. Is 5 seconds. Okay. And green is turned on for 70 seconds. Yellow is turned on for 5 seconds and red for 75 seconds. Acha. In terms of clock is 5 seconds. So 70 is 14 into 5. So this is 14 clock cycles. This is 1 clock cycle. And red should be on for 15 clock cycles. Red should be on for 15. So I need 30 clock cycles. I need 30 T clock. That means 30 clock cycle तक के लिए आपको 30 states चाहिए. So actually you want 30 states, sir. You want 30 states. No, this is gate 22 question, gate 2018 question, sorry. 30 states. For 30 states, how many bits are required? Right. For 30 states. Question solve kar diya. The question is solved in 2 lines. No need to even draw the truth table or nothing. 30 states I need. At least 30 states. Right. Because 1 clock cycle is 5 seconds, right? And yellow is to be there for 5 seconds. So 1 clock cycle for 5. Okay, 14 clock cycles for green because that is 70 seconds and 15 for red. Total 30 states I need. Okay, how many bits I need? 5 bits. Because 4 bits can make 16 states. I need 5 bits. 5 bits can make 32 states, 2 will be unused. 2 will be unused. And every bit, for 1 bit we need 1 flip-flop, right? So how many flip-flops are required here? 5 flip-flops are required. हो गया ना? It's again an aptitude, basic aptitude plus digital logic mixed. More like aptitude. 1 mark question. 5 flip-flops है ना? 5 bits हैं, 2 unused छोड़ देंगे. There will be 2 unused states because 5 bits can make 32. There will be 2 unused states. ठीक है? Done. The answer is 5. यहाँ पे आके fill कर देना इसको. The answer is the 5, dear. That's it. Right. The answer is 5. Done. Very, very simple question it is. Done. Actually, बनेगा कैसे? You know, if I just give you a brief hint. इसकी details में बताऊं briefly. So I need 5 flip-flops, I know. So let the 5 flip-flops are named as respectively Q3, Q2, Q4, Q3, Q2, Q1, Q0, and I have the outputs. I have the 3 LED outputs. इसको थोड़ा सा नीचे करते हैं. Q4, Q3, Q2, Q1, Q0. Just for your understanding, है ना? Just for your interest and understanding. And I have the 3 LED outputs. I need the 3 lights. Right, that is respectively green, yellow, and red. Green, yellow, red. Right, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. But green is on for 14 clock cycles. Right, 14 clock cycles मतलब 0 से लेके go up to 0, 1, 1, 0, 1, 13 तक. 0 to 13 is 14 clock cycles. So what I will do, I will try to design a circuit such that whenever the state is 0, 0, 0, 0, 0 up to 0, 1, 1, 0, 1, my green should be on. Right? My green should be on. General color ले लेते हैं. And other LEDs will be off. Other LEDs will be off. Only green is on. Then there comes the next count. 0, 1, 1, 1, 1. For that, yellow should be on. 0, 1, 0. And yellow is on only for 1 clock cycle. 5 seconds के लिए yellow चाहिए था. Right. For 5 seconds, I want the yellow. And then 1, 0, 0, 0, 0. Up to the 15 clock cycles now. Kitna? Up to the 15 clock cycles. So that will go up to 1. Etc, etc. 1, 1, 1, 1, 0. Correct. 1, 1, 1, 0. नहीं 0 से start किया ना तो 0 से 14. 1, 1, 1, 0, 1. Okay, let's take this. 0, 1, 1. Actually यहाँ पे change करना पड़ेगा मुझे. Slight error. I'll change this and then this goes. Okay. So that was 1, 1, 0, 1. Now after 1, 1, 0, 1, 1, 1, 1, 0 will come and then 0, 1, 1, 1. Up to 1, 1, 1, 0, 1. Okay, you have to design the circuitry such that green is off, yellow is off, red becomes 1. Right. And what about the next two? Right. 1, 1, 1, 1, 1 and sorry. 1, 1, 1, 1, 0, 1, 1, 1, 1, 1. For these two क्या करना है ना? For these two, the output can be treated as don't care. Because these are the inputs not going to come. हम counter ही ऐसा बनाएंगे ना, which counts up to 1, 1, 1, 0, 1 and then directly jumps here. I only need 30 states. And the input which do not come, for them the output will be don't care. They don't care. This is how you can design. Just for your additional knowledge, I have given you this information how to design this FSM. Now you can feed this into the K map. Right, GYR. Next, what you will do is GYR will be written as the functions of Q4 sec Q0. Okay, and then you will minimize it using K map, implement the hardware. That becomes a traffic light signal, the traffic signal controller. But the question was not this much of designing, it will take time. That can be a conventional question in ESE and all. But here it was a logical question in gate, aptitude type of question. How many flip-flops will be required if I want to design this traffic signal? if I want to design this traffic signal. ठीक है, बहुत बढ़िया. अगला क्वेश्चन आते हैं quickly. Our time is 11:15 already. A 10-bit, easy, definitely some basic A to D D2A converters are accepted. A 10-bit D2A converter is calibrated over full scale from 0 to R if the input is 13A in hexa. This is the hexa number. So what is its decimal value? 13A is a hexa number. Okay, what is its decimal value? Okay, so this is 1 into 16 square, 3 into 16 की power 1. A बोले तो 10 into 16 power 0. So this is 256 plus 3 into 16, 48 plus 10. So कितना हो जाएगा ये? Okay, this is 58, 112, 114, 314. चेक कर लेना एक बार चेक कर लेना. This has to be 314. Laddu question for 1 mark. Okay, now what is its analog output? Right, ये इसकी decimal value निकाल ली. Okay, so what is the analog output? Of this digital to analog converter? We know that directly you should be able to write down it is equal to the decimal value of the corresponding binary number. Only thing in rather than binary they have given the hexadecimal value multiplied by the VLSB multiplied by the resolution. And how much is the resolution? It is VR, reference voltage, divided by 2 power n. Reference voltage कितना हुआ? 10 volt, and that is divided by 2 raised to the power 10. Calculate this answer and quickly give me the value. Let me also write down this one quickly. Divided by 2 की power 10, तो कितना बेटा? 3.066 volt. 3.066 volt. Done. 3.066 volt. Done है. Okay, this part is done. Okay. चलो. Guys, this is a very similar question. Unipolar DAC given है again. So kindly try the very similar question. It has the voltage range 0 to 7.68 and the digital input code is given to you. Okay, what is the analog output voltage of the DAC? What is the analog output voltage of the DAC? ठीक है. What is the analog output voltage of the DAC? ठीक है. So you can do this as homework because it's a very similar question. So guys, the time is 11:15. 2 hours of 15 minutes already done. And I think we are done with most of the parts. Number system हमने किया. Boolean के questions हमने कर लिए. Yes. Logic gates question done. Yes. Combinational circuits done. Yes, all questions of combinational. Sequential circuits, including counter, flip-flop, everything. FSM question, state diagram question done. Okay, and ADC and DAC question, whatever questions are there are done. This much is done. ठीक है? This much is done. Only thing is logic family and memories, from which you will have very few questions. From which you generally will have few questions. This is what is the most important things जो आपने अभी तक देखा ना. And maximum session time is spent on this only. The flip-flop question, counter question, shift register based question, state diagram question, FSM, sequence detector. Here the maximum time is spent. Right? Okay. Only these two probably are left and few questions will be there. But let's stop. It's 2 hours of 20 minutes of non-stop session. But I think you've got everything, and that too EC plus EE. It's not only one branch. We have covered EC questions also, EE questions also. इतना हमने पूरा कर लिया है. इतना हमने पूरा EC and EE, so that you have multi-branch practice. You have multiple branch practice. Okay, so with this, I'll stop here for today. Okay, guys, and see you in the next. Now, next in this PYQ, my turn will be with EMT. Tomorrow, you will have analog circuits actually. Okay, tomorrow you will first have analog circuits by Sanjay Rathi sir. Okay. Very, very important subject again. 6 p.m. analog circuits. Okay, dear. Tomorrow 6 p.m. analog circuits, Sanjay Rathi sir. Okay. Next month, Ashraf, it will be there. All marathons in the next month. Stay tuned and stay subscribed to the channel. Technical marathons, aptitude marathons, maths marathon, everything to be there in the next month. Okay. So guys, bye-bye. Thank you. Stay safe. Tomorrow analog circuits will be there. Next week, I'll again be back in the PYQ series with the EMT. EMT I'll be taking again. Bye-bye. Good night. Stay safe and take care of yourself.